So in our lesson today, more uniform motion. So more RT equals D. Two situations for it. So we'll generally have RT equals D with two sets of subscripts. But we are going to know what the distances are. We are going to know what R1 times T1 equals. And we are going to know what R2 times T2 equals. They may be the same, they may be different from each other. So, first example, Friar Tuck rode 24 miles to the fair at a leisurely pace. So I know that was 24. And he stayed too long and he had to double his speed on the way back to get home in time. So then he goes from the fair home. How long is the second distance going to be? So it's also going to be 24. And so then I need to figure out what's going on from the other information that I'm given. So I'm going to use for my subscripts a T for that and a B for the way back, just so that we know what I'm setting up. So I know that RT TT equals 24, and I know that that also equals RB times TB. And right now, I don't know if I want to use RTTT equals 24, or if I want to use RTTT equals RBTB. I'll figure it out as I go along. So right now, I know those three things are all equal. I also know that he doubled his speed on the way back. So how do I write down an equation that says on the way back, his speed was double what it was before? Let's go. So very good. RB equals 2 RT. Are we all comfortable with that? Okay, then we know that the total traveling time was 9 hours. So we're going to say that TT plus TB was 9. And this says how fast in each direction, what are both the rates, and it says what are both the times. So we need to end up figuring out RBTB, TT, and TB. So for this one, I am going to start doing some substituting. I know RB is all by itself and equals something else. So it's probably going to be a good idea if I pick an equation that has RB with some other stuff in it maybe equals something else. So since I have this one by itself, I am going to pick RBTB to substitute into. So I'm going to put the 2 RT in for the RB. And then I want to be consistent. Since I've substituted in here, I want to substitute in for the other thing with the same subscript. I substituted for RB, so I also want to plug in TB equals. So I had to take this equation right here and make it TB equals what? What am I going to have on that one? So 9 minus TT. So far, is everybody good with that? Okay, now I started off with, this was my RBTB equals that, and I've substituted in. Do you think it's going to be more helpful to have this thing equals 24 or equals something with some other variables in it? I think it's going to be more helpful here to say it equals 24. So now let's see what we have. So we substituted in, so we aren't worried about that part anymore. So if we distribute, we have 2RT times 9, so 18RT. 2RT times minus T, I have minus 2 RT RT equals 24. Oh man, I've still got two variables in there. Ted? So very excellent. Our trick is going to be, we're going to substitute in for two variables at once. We don't know yet what RT and TT are separately, but we know anytime they're multiplied together, they are equal to 24. So I'm going to change this RT-TT to a 24, which means I have 18 RT minus 2 times 24 is 24. So let's see, what's that going to give us? 18 RT minus 48 is 24. And if I add the 48 on both sides, 18 RT is 72. Does that look right? Divide both sides by 18. And can anybody tell me what we have? So is everybody comfortable with RT needs to be 4? Okay, we need to label our units on that. It was miles and hours, so miles per hour. Now we go back to our other equations and pick ones that will let us get the other things. So we come back up here. We now know RT. So what do you want to find next? As you look at those equations up there, there's at least a couple of things you could choose to do next. Help me out here. As you look at this, all eyes should be up here. Look at, I just put boxes around the RTs. Look at my original equations up here. What can I plug into and get what else? What do you want to solve for next? Charlene? So if we do this top one, so Charlene wants to plug in on that. We just said RT was 4. So if 4TT is 24, everybody shout out, what's TT? 6, what will my units be? Okay, now we know RT and we know TT. We still need to get the B's. Which one do you want to get next? Look at the things that are boxed in those equations. What should we do next to be able to get there? Kira? Okay, so if we go to this one next, RB is 2RT. That means that RB is 2 times RT was 4. So RB is 8. What will my units be for that? So miles per hour, because that's the rate. So now we know everything except TB. So which equation do you want to use to get TB? Jonas? Okay, so we could use either one. There's not a right or wrong answer. So if RBTB is 24, that means 8TB needs to be 24. So everybody, what's TB? And hours. And does that make sense? If I look at the other equation, my times were 6 and 3. Do they add up to 9? So any questions with that one? So they're kind of messy, and you just got to keep looking, well, what should I do next? All right, next example. Bernard raced twice as fast as Joanne. If we're talking about how fast somebody's going, what is that, rate or distance? Or so rate. So Bryce, would you please give me an equation? I'm going to use B and J for my subscripts that says Bernard's rate was twice as fast as Joanne's. Thumbs up, thumbs down. How do you guys feel about that equation? All right, so then we know that Bernard went 120 miles. So I'm going to write down that Bernard's distance is 120. Does that equation make sense? Jonas, question? Kind of is going to depend on the context. If they aren't starting and stopping at the same place, then we definitely will. Right now, I'm just kind of trying to figure out, well, what's going on. I don't know if these people started at the same place and ended at the same place, so that's why I'm not drawing a picture, at least yet, unless I get some more information in there. Okay, and we know Joanne went 105 miles. So this time it's two different distances. And remember I said sometimes the distances are the same and sometimes they're not. This is an example where they are indeed different distances. And let's see, so I've used the twice as fast stuff. I haven't used the 3-hour thing. Can anybody help me out with an equation that talks about that 3 hours less stuff in there? Ted? And let's see what the class thinks about that. Bernard took 3 hours less than it took Joanne. Does that make sense to everybody? What would somebody else want to do? What would you want to do, Charlotte? How many of you like that? Are they different? Or are they the same? How many think they're the same? Give me a thumbs up. Give me a thumbs down if you don't think they're equivalent. If I subtract 3 on both sides on this one, don't I get this? So either way is fine to do it. I talked through that because our brains all work differently. I usually say Bernard's time is 3 hours less than Joanne's, so Joanne's -3. But it's totally okay if you think about it the other way first to get it set up. All right, now we want to figure out both rates and both times. So we have RB equals 2RJ, or RJ equals half RB. Would you rather do it like it's written on the board, or would you rather I change that and do fractions? Because I want to substitute RB equals and TB equals, or I want to put in RJ equals and TJ equals. Would you rather put in 2RJ, or would you rather plug in a half RB and work with fractions? Help me out here. Which way would you rather? I'll do it whichever way you think is better, but you guys have to tell me. Baylor, what do you think? Would you rather do it with the 2 or with the 1/2? 2? So thumbs up for 2. So that means I want to plug in for the B's. So that means I'm going to take this equation and put in 2RJ for that RB. That also means I'm not going to use this form on the left because it's TJ equals. I am going to use TB equals so I can plug in for both, just to be consistent there. So then I put in the TJ -3 right here equals 120. So let's distribute again. 2RJ times TJ is 2RJ TJ minus 2RJ times the 3 minus 6RJ equals 120. So Alexander, now what can I do? Okay, so RJTJ, and I have to be careful because the distances are different. RJTJ, that distance is 105, and that is multiplied by 2, minus 6RJ is 120. So let's see, that is 210 when I multiply. So if I subtract 210 from both sides, I guess that's okay because I've still got the minus 6RJ. And what am I going to get when I subtract? Negative how much? So negative 90. Divide both sides by the negative 6, so RJ will be positive, which is what we want. And who can tell me positive what? So everybody, I'm hearing 15, and let's check where our unit's still miles per hour. So far we've found one of those. So now we know RJ. And so I want you to decide, what do you want to find next? I see two equations with RJ in it, and you tell me what you would like to find next. There's not a right or a wrong. Ricky, what do you want to find next? Okay, so you wanted to use this one, and we just said RJ was 15, so 15 TJ is 105. Divide by 15s, and who can tell me what TJ needs to be? Already got that? Everybody good with 7? And those were hours. So now we have the RJs, and we have the TJs. So which of the B's do you want to find next? Look at everything I've put a box around and tell me whether you want to find RB or TB next. You could do either one. Sabrea? What? So Sabrea wants to do TB, which means this equation here. So TB will be TJ, which is 7 minus 3. Everybody shout out, what's TB? And that means now we've got TB also. So I just need RB. I can either do RB as 2 times RJ, or I can do RB times my 4 is 120. I don't care which one. Which do you prefer on them? Sonia, which one do you want us to use? Okay, so Sonia picked RB is 2RJ. And let's see, I got to find my RJ here so I remember. So 15. So RB is 30 miles per hour. Any questions with that? Jonas? Three hours less than Joanne. So let's see if our answers make sense. So Bernard's time was 4 and Joanne's was 7. Was Bernard's 3 hours less than Joanne's? That makes sense. It also says Bernard went twice as fast. Bernard went 30 miles an hour and Joanne went 15 miles an hour. Does that make sense that Bernard went twice as fast? And that's always a good idea. So thanks for bringing up that question. That's always a good idea. Before you go on to the next one, just real quickly, look back at the context of your problem. Did your answers make sense? Yep. Okay, now let's go on to the next one. Any other questions from anybody? Then how about some